Hi folks, this is the next video for Year 13 differentiation. We're looking at 9H, that's right, implicit differentiation. This is where, hang on a minute, let me write that. So if I have a function that's not necessarily in terms of x, but I want to differentiate with respect to x. For example, let's say I have this thing called a, and it's actually a function of y. Well, I want dA dx. I want the derivative of a with respect to x, but I can't get to that very easily because it's not actually a function of x. I can get dA dy pretty easily. Remember, I can treat these things like fractions because the dy's, if you like, the dy's would cancel out. So again, this is just an implementation of the chain rule. So here, dA dx, I differentiate with respect to y and multiply by dy dx. That is dA dx. Well, it's an expression for dA dx. Now, as abstract as that looks, it's useful when we have expressions that are functions of both x and y, and it's either difficult or impossible to make x or y the subject. For example, if I have x cubed plus x okay, so what I'm saying is I'm going to differentiate through by with respect to x. So this bit's straightforward enough. Differentiate with respect to x. I can't differentiate y cubed with respect to x, so I differentiate with respect to y and multiply by dy dx. Same here, can't differentiate with respect to x, so differentiate with respect to y and multiply by dy dx because of the chain rule. And of course, I can differentiate with respect to what's on the right hand side, it's just a constant. Now I make dy dx the subject, so dy dx 3y squared plus 3. So I've taken dy dx out as a common factor, and I'm going to move both of those terms to the other side. So dy dx is an expression which contains both x and y. And that makes sense because, if you like, my original equation had terms in both x and y. That was example 21. Example 22, same deal, except there's a product rule and a quotient rule involved. So example 22. 4x, so this is a product, the product of 4x and y squared, so I'm going to use the product rule for this term. There's a quotient, I'm going to use the quotient rule for this term. Okay, so let's just differentiate 4xy squared. Product, u is 4x, u dash is 4, v is y squared, v dash is 2y dy dx, and the product rule is u dash v plus uv dash, so u dash v 4y squared plus uv dash 8xy dy dx. So that's my product rule. I'm going to do the quotient rule here. Not quite how they do it in the book. They write it as 6x squared times y to the minus 1. They use the product rule. I'm going to use the quotient rule. So just to differentiate 6x squared over y, u is 6x squared, u dash is 12x, v is y, v dash is 1 dy dx. and it's u dash v minus uv dash over v squared. So u dash v 12xy minus u v dash 6x squared dy dx all over y squared. I've just fit that equals 0 on the end. Okay, so 4y squared plus 8xy dy dx plus, let's write this as two separate fractions, 12xy over y squared minus 6x squared over y squared dy dx. Just managed to fit the equals 0 on again. And make dy dx the subject. I've got 8xy minus 6x squared over y squared. Oh, my pen's running out. Let's go blue. Equals, I'm going to take minus 4y squared over and minus 12xy over y squared. Dy dx is equal to this expression. Now, this doesn't look like the expression in the book. I'm sure I can simplify, but I'm not going to bother because actually they want me to sub in. So dy dx when x equals 1 and also y equals 1, minus 4 minus 12 over 8 minus 6 minus 16 over 2 minus 8. So although the expression looks different to the one in the book, they've done it differently to me. They didn't use the quotient rule here. And of course you could write it as a product and use the product rule. Doesn't really matter, of course, as long as your answer is correct. So that was example 22. Example 23. What have we got? E to 2x log y equals x add y minus 2. Product rule here. So let's do a quick product rule. U is e to the 2x. So u dash is 2e to the 2x. V is log y. So v dash is 1 over y dy dx. And it's u dash v plus u v dash. So u dash v 2e to the 2x log y plus u v dash e to the 2x over y dy dx. The right hand side is straightforward enough. 1 add dy dx, and of course the minus 2 is a constant. So I'll make dy dx the subject. Or do I want to sub in first? No, I think I'll sub in first. It doesn't really matter, does it? Sub in 1, 1. Okay, so 2e squared log of 1 is 0 times 0 plus e to the e squared over 1 times by dy dx is 1 plus dy dx. So e squared dy dx equals 1 plus, oops, don't know where that 2 came from, think I was thinking a step ahead. So dy dx e squared minus 1 equals 1. So dy dx equals 1 over e squared minus 1. Done and done. Oh, that's it. Okay. 9H then, folks. Give that a shot. Let me know if you need anything. See you next time.